Good day and welcome to Big Bad Tech. I'm your instructor Jim Pytel. Today we'll discuss magnetic motor starters incorporating a jogging or inching function. Our objective is to define jogging or inching and examine several configurations of ladder logic incorporating a jogging function. Additionally, we'll discuss the suitability of contactors both making and breaking inrush current. This lecture operates under the assumption you have watched both the 2 and 3 wire magnetic motor starters and friction brakes lectures available at the Big Bad Tech channel, and are intimately familiar with holding circuits as presented in the basic ladder logic lecture. If you haven't watched these lectures yet, or only dimly recall their contents, please take the time to do so now. First and foremost, jogging or inching is the act of briefly energizing a motor for the purposes of partial rotation or small movement. Such an action could be used to align a shaft with a coupling or to briefly move an applied load. Jogging or inching is a momentary act and does not use a holding circuit. A holding circuit, as you'll recall, is utilized in a 3-wire control circuit and maintains the last asserted state. Let's review the operation of a regular 3-wire control circuit since it's an essential component to our discussion. Pilot voltage is ordinarily supplied by a control transformer stepping down the line-to-line voltage to a suitable pilot level or a DC power supply. The first rung of our ladder logic consists of a maintained contact, normally closed e-stop, in series with a momentary contact, normally closed stop push button, in series with a momentary contact, normally open start push button, in series with the M contactor coil, in series with a normally closed overload contact. The second rung includes a holding contact, M1, associated with the M contactor in parallel to the momentary contact normally open start push button. If an operator were to press the start button, the momentary normally open start switch would close, and via the normally closed e-stop, the normally closed stop, the now closed start, and the normally closed overload contact, the coil of the M contactor would be energized. When the coil of the M contactor energizes, its associated contacts change states. The normally open M1 holding contact in parallel with the start push button closes, and the primary M contacts close. The motor experiences inrush current and begins rotating. Once the motor reaches rated speed, the inrush current subsides and levels out at the full load rated current. If an operator were to release the momentary contact start button, the spring return would return it to its normally open deactivated state. Note that the now closed M1 holding contact maintains the energized state of the M contactor coil. This means that the primary M contactor stays closed and the motor continues spinning as intended. That's the point of the holding circuit. It maintains the last asserted state. To stop the motor, an operator must press the normally closed stop push button. The now open stop de-energizes the M coil and the associated contacts return to their de-energized state. The M1 holding contact opens, removing the path in parallel to the start push button, and the M contactor primary contacts open and the motor free spins to a halt. Notice while in its natural deactivated closed state, the maintained contact e-stop in no way, shape, or form affects functionality of this system. When an operator presses and releases start, the motor starts. When an operator presses and releases stop, the motor stops, ready to initiate another start cycle. If, however, an operator were to observe an unsafe scenario, by hitting the maintained e-stop, the motor would stop and the system would be disabled. Importantly, due to the maintained rather than momentary nature of the e-stop, the system will remain disabled until the e-stop is reset. The start button will not energize the M coil, and as such, the primary M contactor will not close despite repeated attempts to do so. That's the point. The maintained e-stop has disabled the system. Only after the e-stop has been reset and returned to the closed position can the system now start the motor. If this motor was subjected to a high inertial load while running, the 3-phase AC system lost a phase, or the rotor was somehow locked due to a misaligned shaft or bad bearings, the normally closed overload contact would de-energize the M coil. Only after the overloads cool and reset can the motor be restarted. Recall that 3-wire control circuits like this are no-voltage protection circuits, and that an operator is protected from the sudden starting of the motor. If power is lost and restored, or if the motor has been subjected to a thermal overload, the holding circuit drops out and the motor will not restart until an operator makes the conscious decision to actively do so. Note that upon closure of the primary M contactor, the motor is instantaneously and directly connected to full voltage upon closure of the contacts. Such an event is characterized by a large surge of current known as inrush. Inrush can be about 6 times normal full load current, and direct online motor starters like this must be obviously rated to carry this current. Inrush current, although intense and undesirable from a distribution standpoint, is ordinarily brief. As a motor comes up to rated speed, increasing counter-electromotive force, sometimes called CEMF, opposes the applied voltage, and current quickly drops to a reasonable level. We'll return to discuss this associated phenomenon as applied to jogging circuits in a moment. Note that the holding contact M1, in parallel to the momentary contact normally open start push button, maintains a current path when the M coil is energized. All it's stopping us from creating a jogging circuit is removal of the M1 holding contact. Notice when the M1 holding contact is removed, the momentary contact normally open start push button energizes the M contactor coil only when an operator is in the act of actively pressing it. When the M contactor coil is energized, the primary M contactor would close. The motor would experience inrush current and begin rotating. The moment the operator releases the start push button, the spring return returns it to its deactivated open state. The M contactor coil would then be de-energized and the primary M contactor would open. The motor would free spin to a halt. Without the M1 holding contact, an operator could briefly energize the motor to inch the shaft or applied load along until it reaches the desired location. As currently implemented, the accuracy of small movements is complicated by the fact that the motor, when the primary M contactor open, free spins to a halt. It is for this reason motors to be jogged or inched often include spring-applied, electrically released friction brakes. When the primary M contactor is closed, the brake solenoid is energized and the electrically released friction brakes are disengaged and the motor is allowed to spin. When the primary M contactor is open, the brake solenoid is de-energized and the set spring engages the friction brake, thereby bringing the motor to a rapid halt. The incorporation of spring-applied, electrically released friction brakes isn't necessarily mandatory for all applications, however, does increase the accuracy of jogging or inching movements. Far more important than brakes, a jogging circuit is a circuit incorporating momentary switches without a holding contact in parallel. In contrast, a 3-wire control circuit with a holding contact maintains the last asserted state. The functionality of both maintained run and momentary jog circuits can be created by incorporating a maintained contact selector switch in the second rung. The selector switch target table shows the contact is closed in the run position and open in the jog position. The selector switch is effectively enabling the holding contact in the run position and disabling it in the jog position. Let's take a closer look at this run-jog circuit making use of a selector switch. If an operator were to press the start button while the selector switch was in the run position, the momentary contact normally open start switch would close, and via the normally closed e-stop, the normally closed stop, the now closed start, and the normally closed overload contact, the coil of the M contactor would be energized. When the coil of the M contactor energizes, its associated contacts change states. The normally open M1 contact in parallel with the start push button closes, and the primary M contacts closed. The spring-applied, electrically released brakes are disengaged, the motor experiences inrush current, and it begins rotating. Once the motor reaches rated speed, the inrush current subsides and levels out at the full load rated current. If an operator were to release the momentary contact start push button, the spring return would return it to its deactivated normally open state. Note that via the selector switch in the closed run position and the now closed M1 holding contact maintains the energized state of the M contactor coil. This means the primary M contactor stays closed and the motor continues spinning. That's the point of the selector switch in the run position. It keeps the M1 holding contact enabled and maintains the last state. The e-stop, stop, and overload contacts function as previously. In contrast, with the selector switch now in the jog position, the M1 holding contact is essentially switched out of the circuit. When an operator presses the momentary contact normally open start push button, it energizes the M contactor coil. When the M contactor coil is energized, the primary M contacts close. The electrically released brakes are disengaged. The motor would experience inrush current and begin rotating. The moment the operator releases the start push button, however, the spring return returns it to its deactivated open state. because the parallel path afforded by the M1 holding contact is no longer available due to the open selector switch in the jog position, the M contactor coil would be de-energized and the primary M contactor would open. The spring-set electrically released brakes are engaged by the spring and the motor is brought to a rapid halt, having accomplished a very small movement as intended. The e-stop, stop, and overload contacts function as previously. By incorporating a selector switch that selectively enables or disables a holding contact, we have created a motor starter with two modes: a run mode that maintains the last asserted state, and a jog mode that allows an operator to momentarily energize a motor.